Hi guys, welcome to my another video. In this video, I am gonna teach you the continuation of isomerism. Last video I have explained about position isomerism. Now I am going to explain about functional isomerism. Functional isomerism definition is same molecular formula but differ in functional group. Now here the first type of functional group is alcohol plus ether. Alcohol plus ether. Example of the general formula of alcohol plus ether is CnH2n plus 2 into O. Here is example for alcohol plus ether is C2H6O is in type of alcohol is CH3CH2OH, and in type of ether is CH3OCH3. And the second example is C3H8O. We can write it in type of alcohol has this, and type of alcohol is this, and type of ether is this one. Here the first structure IUPAC name is propanol, and second structure IUPAC name is propane to all, and third structure IUPAC name is ethyl methyl ether. Here we observe that it has same molecular formula but differ in functional group. If we observe first and third structures, we observe functional group isomerism, and second and third structures also we observe functional group isomerism. We have same structure but differ in functional group. Here we have in second structure we have alcohol, and third structure we have ether. Okay guys, next example is C4H10O. Here we divide here into alcohols and ether. Alcohol and ether. Here we write in type of alcohols is CH3CH2 CH2CH2OH, and we can write two types of alcohols. Here we can write this type of ether conditions for this molecular formula. We can write this type of structures. We have another type of structures also. I will show you now. Wait for 1 second. Okay guys, here alcohol we can write like this, and here I have showed you two types, and these two types we can write alcohol condition, and we have three types, and this is the third type of ether of the molecular formula. Here in this fifth and sixth are metamers, and fifth and seventh are metamers. Here metamer means it is also type of isomer. It is same molecular formula. Its definition is same molecular formula and same functional group but size of alkyl groups are different. And the second type of functional group is amine. Here we need three degree amine, first degree amine and second degree amine and third degree amine to write a molecular formula and write its structures. First degree amine is CH3NH2, and second degree amine is CH3NHCH3, third degree amine is CH3NCH3CH3. The general formula of this amine is CnH2n plus 3n. Here for first degree it is C4H11, and we can write the general formula. We can write like this for first degree, second degree and third degree. We can write like this molecular formulas, and etc. We can write more than this also. Okay, done. Okay, here C3H9N is another example of amine. In this first degree we can write as CH3CH2CH2NH2, and second and we can write two types, and the second type is CH3, and the second degree means structure is this one, and third degree means structure is this one. Here we observe second and third we have functional group, and first and second we have position isomerism, and third and fourth we have functional isomerism, and first and fourth we have functional isomerism. Here, see, here we observe same structure and same molecular formula but differ in functional group. Okay guys, next I'm going to explain you another. Yes guys, the another example is C4H11N, and in type of first degree we can write it as C and N. We have 4 types of first degree, and second degree we have 3 types, and third degree we have only 1 type. We can write it 2 types here. And the next third type is cyanide and isocyanide. Here cyanide is Cn and isocyanide is Nc. Here we can write cyanide as CH3Cn and isocyanide as CH3Nc. And the fourth type of functional group is nitro and isonitro. We can write nitro as NO2 and isonitro as ON double bond O. Here we can write nitro as like this, and we can write it also like this. Next one is amides. Next one is amides. We can write amides as like this. Wait guys, I'll explain you. Yes guys, amides. Here we can write amides as C double bond O NH2, and aldoxymes as CH double bond N OH. Here we can write this amide as this structure also, and aldoxymes as this structure also. And the next one is acid and ester. Acid structure is COOH, and acid is carboxylic acid actually. Ester is COOR structure is molecular formula is. Okay guys, the general formula of acid and ester is CnH2nO. The example of this is CH3C double bond OH, and this structure can be written as methyl methanoate, and this structure can be written as CH3C double bond O can be written as ethanoic acid. Here the two examples of this are, this is carboxylic acid and this is ester. Okay, this structure we can write as propanoic acid, and this structure we can write as methyl ethanoate. And the next type of aldehyde and ketone, the general formula is CnH2nO. We can write it has a double bond equivalent. Here the formula is C minus H/2 plus N/2 plus 1. Here we have 3 carbons and 6 hydrogen and 1 O. If we will substitute there, and then there we get 1, that indicates that it has 1 double bond and 1 ring. Here in the case of aldehyde we have this structure, and in the case of one we have this structure. In the case of ether we have these 3 structures. Here ether condition, here we have 3 carbons and 6 hydrogens and 1 O, and here to have 3 carbons and 6 hydrogens and 1 O. Here to the same. Okay guys, here aldehyde and ketone has, here we see here 3 carbons and here also 3 carbons and 6 hydrogens here also, and in 6 hydrogens in the case of ketone and 6 hydrogens in the case of aldehyde, and 3 carbons in the case of aldehyde and 3 carbons in the case of one, and 1 oxygen in the case of aldehyde and 1 oxygen in the case of ketone. Here we can say that these both are equal but differ in function group. I hope you like this video. Please like, comment, share and subscribe to my channel, and don't forget to click the bell icon. Thank you for watching.